Okay, this problem says, what is the impedance of a series combination of 50 ohm resistor, a 5 microfarad capacitor, and a 10 microfarad capacitor at a frequency of 2 kilohertz? Okay, let's draw a diagram first. Here's the resistor, and we have two capacitors in series. Okay, so we'll call it C1 and C2. This is R is 50 ohms, 5 microfarads, and 10 microfarads. Okay, what the first thing we want to do is to reduce this to a single capacitor. And the equivalent capacitance is given by 1 over C1 plus 1 over C2. So we'll work in microfarads. This is 5 microfarads and 10 microfarads. And 1 over C equivalent is 2 plus 1, 3 over 10. So C equivalent is 10 over 3 equal to 3.33 microfarads. Alright, so now we found that. Now Z, the impedance is given by, for a resistor and a capacitor in series, plus XC squared. And let's find XC first. XC is 1 omega C, which is 1 over 2 pi FC, which is equal to 2 pi, and the frequency is 2 kilohertz, 10 to the power 3 hertz. And C equivalent is 3.33 into 10 minus 6 farads. Alright, so let's figure this out. This would be, let's take care of powers of 10, and that's 10 to the power 3 minus 3 minus 6 minus 3, that comes to the top, that becomes plus. So that's 10 to the 3, well actually let me do it on a new page. Okay, so XC is 10 to the power 3, and this is an impedance, and the units are, so this is 1 over second, omega is units of 1 over second, so seconds divided by farads, and that's ohms. Anyway, all impedance have units of ohms, so what we have is 10 to the power 3 divided by, in the denominator we have 2 pi 4 pi times 3.33. So 3.33 times 4 pi. And this works out to 23.9 ohms. Okay, so the impedance of the resistor and this equivalent capacitor in series is, and that's 50 square plus 23.9 square ohms. And this works out to 55.4 ohms. So at 2 kilohertz, that's the frequency. And notice that as the frequency increases, XC decreases, the impedance of the capacitor decreases. So in the limit omega going to infinity, Z would go to 50 ohms. Yeah. All right, that finishes that problem.